Welcome to this explainer on mastering string manipulation, an absolutely crucial toolkit for scoring top marks in your Cambridge IGCSE 0478 computer science exam. I am seriously thrilled to guide you through this today. Think of string manipulation as your ultimate superpower for handling text in your code. It's not just about making things look pretty, it's about controlling data, preventing errors, and proving to the examiner that you truly understand how computers process human language. Think of your exam like a high-stakes cricket match. You need to set your field, you need to read the bowler, who in this case is the examiner, and you need to score your runs, which are your marks. String manipulation is one of those technical deliveries examiners love to throw at you to test your fundamentals. Okay, let's dive right into this and get you ready. So, taking a quick look at today's agenda, we're covering 6 essentials. First, the power of strings. Second, joining text together. Third, finding your way with indexes. Fourth, extracting data using substrings. Fifth, changing text case, and finally, looping through characters.
All right, let's kick things off with Section 1, the power of strings. We really need to establish why manipulating text is so fundamental to programming and, of course, your exam success. You know, words sit at the very heart of human communication, and because of that, natural language simply has to be at the heart of computing. From the internet search engines we rely on every single day to the predictive text that constantly fixes our typos on mobile apps, technology relies incredibly heavily on the string data type. As a programmer, you use string variables to validate what a user types in and to communicate effectively right back to them. If you can't manipulate strings, you literally can't build a user-friendly program. The examiner knows this, which is why they test it so rigorously. You have to show them you can handle text dynamically.
Moving on to Section 2, joining text together. Let's look at how to build and link text seamlessly.
Concatenation. Okay, it's a massive word, but as this definition shows, it simply means to link together. It's gluing pieces of text to one another. Concatenation is what gives context to your raw data. Imagine you calculate the area of a room in your code, and the computer just spits out the number 20. Well, 20 what? Centimeters? Light years? Pizzas? By concatenating the variable holding the number 20 with the text string square meters, you create a meaningful output message that the user actually understands. It bridges the gap between raw calculation and human readability.
Before we continue, subscribe to our YouTube channel, Ace the Exams at Ace the Exams IGCSE, to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, here is your first major syntax showdown for the exam. And it is a classic trap the examiner sets for you. You absolutely have to know the difference between your specific programming language and your default pseudocode. If you're using Visual Basic, for example, it uses the ampersand symbol, the and sign, to indicate concatenation. But when you are writing out pseudocode in your exam, the standard symbol for concatenation is actually the comma. Mixing these up is such an easy way to drop marks. It's like misreading the spin on a cricket ball. You'll get caught out immediately. Lock this difference into your memory right now.
Another ridiculously easy place to lose marks is your formatting. When you link a variable and a string together, you have to remember that the computer does exactly what you tell it to do. No more, no less. It doesn't understand human grammar or spacing unless you code it. If you don't explicitly add a space, your output will just mash together into one giant unreadable word. It'll look like 20 square meters all is one block. Always, always remember to insert a space at the end of your text statement or at the beginning of the next one when concatenating. It shows the examiner you are thinking like a real developer. All right, Section 3, finding your way with indexes. To manipulate strings, you really have to know how to navigate them using index locations. Think of this as the coordinate system for your text. This visual right here is absolutely critical for your exam memory. I want you to picture this grid every time you see a string question. Every single individual character in a string gets a unique numerical index. It's exactly like a street address for each letter. Take a look at the word computer. Notice how the C is at index 0, the O is at 1, the MUM is at 2, all the way down to the R at index 7. This is the foundation of everything we're going to do next. You have to visualize a string not just as a word, but as an array of individual characters. Now, watch out for this massive examiner trap. Just like we saw with concatenation, there is a fundamental difference in how strings are handled depending on what language you're writing in. Visual Basic uses a zero-based index. That means the very first character is always at index 0, and the final index location will always be exactly one less than the total number of characters. But standard pseudocode typically uses a 1-based index, meaning the first character is at index 1.
If you apply Visual Basic's zero-based logic to a pseudocode question, your entire program will be off by one character, and you will lose those marks. Read the exam question carefully to know which environment they are testing you on.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. So, getting back to it, a crucial point is knowing exactly how long your string is to begin with. When finding how many characters are in a string, Visual Basic uses the len function, while pseudocode uses the fully spelled out length function. They do the exact same thing, but as we know, syntax matters. And here's a massive pro tip that catches so many students out. Remember that spaces count as characters too. If your string is Hello World with a space right in the middle, that blank space has its own index location and it absolutely adds to the total length. Don't ignore the invisible characters. Okay, let's jump to section 4, extracting data using substrings. Let's look at how to pull specific, targeted pieces of data out of a larger string. Substringing. It sounds complex, but it really just allows you to extract exactly what you need. Imagine you have a full name stored in a variable, say Richard Morgan, and you only want to extract the first initial R to create a username. You use substringing to isolate that specific character based on its index location. And the best part? The original string value remains completely unaltered. You are just taking a copy of the specific section you requested. It's like taking a photocopy of one page from a book. The book itself stays perfectly intact. Let's break down Demo Task 11.2 straight from your source material. This is a classic, multi-step exam problem, the kind of question that separates the top-tier students from the rest. The system requires taking a single company email address, like sales@thebusiness.org, and outputting 2 separate values, the recipient name, which is sales, and the company element, which is thebusiness.org. You can't just guess where the split is because every email is a different length. Let's look at the logic required to actually solve this algorithmically. To solve this logically, we break it into 3 distinct steps. Step 1, you need to find the pivot point. You use an index of command to find exactly where the @ symbol is sitting. Let's say, in our example, it's sitting at index 5. Step 2, you substring from the very start of the email, which is index 0, and you grab 5 characters. That neatly gives you the recipient name, sales. Step 3 is the slightly trickier one, getting the company domain. You need to substring starting from the index after the @ symbol. But how many characters do you grab to get to the end? You calculate the total length of the email and subtract the index of the @ symbol plus 1. That little bit of math gives you the exact number of characters needed for the domain, no matter how long the email is. It's a really beautiful piece of logic when you put it all together. Moving on to section 5, changing text case. Next up is modifying the capitalization of strings. This is an absolute lifesaver when you are checking inputs provided by a user. Both languages give us specific commands to force text into upper or lower case. Visual Basic uses 2 upper and 2 lower, while pseudocode uses UCase and LCase. What's incredibly helpful to remember here is that these functions only affect alphabetical letters. If your string contains symbols like an exclamation mark or a $sign or numerical digits, they remain perfectly unaltered. You don't have to worry about a number 5 suddenly turning into some weird symbol just because you ran an uppercase function on it. And this brings us to a really fantastic exam strategy. Converting values to uppercase allows for a direct, foolproof comparison. Think about it. If your program asks a user to type in computer science, they might type it in all lowercase or all caps or a chaotic mix of both. If you try to write an if statement to check their answer, your program might fail just because they accidentally had their caps lock on. By immediately running their input through a 2 upper or UCase function behind the scenes, you completely remove the complication of unexpected cases. You can validate their answer flawlessly every single time. It makes your code robust, and examiners love robust code. Finally, we reach section 6, looping through characters. Let's combine our tools for the ultimate programming challenge, systematically moving through every single character in a string. Whether you are tasked with encrypting a secret message or just counting how many spaces are in a paragraph, the fundamental approach is exactly the same. You set up a for loop. Step 1, start your loop counter at 0, which is your first index. Step 2, end the loop at the total length of the message, -1. Remember what we talked about earlier? Zero-based indexing means the last character's index is always 1 less than the total length. Step 3, Inside the loop, you use your substring command. You pass in your loop counter variable as the starting index, and you set the length parameter to 1. This brilliant little structure isolates exactly one character per iteration, letting you process the entire word, letter by letter, from start to finish. But beware, looping and substringing bring us to our final danger zone. How do you avoid an out-of-index range error? This happens when your code aggressively attempts to look for a character at an index that simply doesn't exist. For example, if the word hello has indexes 0 through 4 and your substring command tries to grab characters up to index 6, your program won't just output a blank, it will completely crash. Be highly, highly vigilant with your math, especially when combining the len function with zero-based indexing. Trying to substring beyond the actual index limit is one of the absolute most common ways to break your program and hemorrhage those precious exam marks. Always double-check your loop boundaries. Students who implement these exact strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by. So are you ready to spot those indexing traps and master the syntax showdowns in your exam? By understanding these core concepts, concatenation, indexing bases, substring math, and case conversions, you now have the complete developer's toolkit. You understand exactly how Visual Basic and pseudocode differ, and you know how to handle text like a pro. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Keep practicing those logic steps, watch out for the zero-based traps, and good luck.